For Algebra 2 Honors, Unit 1, Day 3. This is relations and functions and inverse functions. So what is a relation? A relation is a pairing of input values with output values. So if I give you that the input is -2, the output is 2, so forth and so on. The domain is the x values. So the important part here is knowing that x values go with domain and the y values go with the range. A function is a relation in which each input only has one output. And that actually leads into the vertical line test, a method used to determine if a relation is a function or not. If a vertical line passes through a graph more than once, the graph is not a function. So basically, if your x's repeat, it's not a function. So if I look here, this is not a function because my x value is repeated in this set of ordered pairs. You can see it here. And if I did the vertical line test here, I see that this line that I drew, there are 2 points on that line at the same time, and I can't have that. So this would just be a relation. It's not a function. Example 1 says identifying functions. So first number in the ordered pair. And usually when you write them from least to greatest. And we're going to write them as a set. So I'm going to use the brace. Okay. So I've got negative. Write it one time, and then I'm going to close it. So that is a set of numbers that belong to the domain. Then I have my y values, which is the range, which are obviously the second part of the ordered pair, 2, 4, 9, -3, and 5. Again, you don't have to put them in least to greatest, but I advise that you do it. Just makes it a little bit easier. So -3, 2, 4, 5, and 9. And it asks, is it a function? And the answer is no, it is not a function. And the reason it's no is because the -1s and the x value repeated. And if it repeats in the x, it is not a function. So part B, for this, again, we have our domain, which is our x, and our range, which is our y. So for your domain, we're just looking at the x here. And those are already in order, least to greatest. Your y's, 3, 5, 8, and 12, nothing repeats there. Okay, is it a function? Yes. There is no repeating numbers in the x value. Okay, for letter C, my advice is to write out, I've got a number, a -4, 1, a -3, -2, a -2, -5, -1, -3, and 3, -1. All right, so I have my x's, which is a lot of them, -5, -4, -3, -2, 1, and 3. And for the range, -5, -3, -2, -1, 1, 4. Is this a function? Yes. If I were to do the vertical line test, every time I see a point, it passes one point on that line. Again, only 1 point. Only 1 point. And when I wrote out all the ordered pairs, I see the x didn't repeat at all. So that's a function. All right, so in example 2, it says the monthly average water temperature of the Gulf of Mexico in Key West, Florida, varies during the year. In January, the average temperature is 68 degrees Fahrenheit. In February, it's 70 degrees Fahrenheit. March, 75 degrees Fahrenheit. And in April, is 78 degrees Fahrenheit. How can you represent this relation in 4 different ways? Okay, well, we have changed that to 3 different ways. So if January is equivalent to 1 and February is equivalent to 2, so forth and so on, how can we write this as an ordered pair? Well, if January is 1, then we know that in January the temperature is 68. And February is 2, which is 70 degrees. March is 3 at 75, and April is 4 at 78. Can you convert that into a table of values? Absolutely. You've got your X's and your Y's. Okay. And we know that we have our months, 1, 2, 3, 4, and they go with their dates. So 68 is 1, 70, 75, 78. Can you graph it? Yes. Okay, so here's what I would do. If my X's are 1, 2, 3, 4, this already is labeled your X. That's always your X-axis anyway. So I would say 1, 2, 3, 4. I skipped a line. You don't have to. You could put 1, 2, 3, 4. Either way. And then here I'm starting at 68 going to 78. It looks like 68, 69, 70, 71, 72, 73. Okay, so we're going to have to count by 2's because we can't fit 68 to 78 on here unless we count by 2's. So let's do 68. This little squiggly line here shows there's a gap from 0 to 68. So 68, 70, 72, 74, 76, 78, and 80 at the top there. So at 1, we're at 68. At 2, we're at 3, 78. And 4, oh, sorry, 3 is 75. 75. And 4 is 78. So this relation is represented in ways: ordered pair, table of values, and a graph. All right, the next part of this note is function notation. So function notation uses the symbol f of x for a dependent variable of a function. This is very important that you understand that it just replaces y. Okay, so if I see y equals negative 3x plus 4, and there's f of x there, that's okay. It's just a y. All right. So now it says evaluate f of x equals negative 3x plus 4 when f is 5, or when it is f of 5. So here's what we're going to do. You're going to take that 5, and you're going to plug that 5 into the x. Okay, so f of 5 equals negative 3 times 5 plus 4. Now, this part right here, that does not mean f times 5. That just means that on the graph, if you were looking at y is 5, if you were looking at x is 5, what is the y value? What's the output that you get when you solve this? So, this is negative 15 plus 4, and that is negative 11. So you write this. When f is at 5, then that is at negative 11. Okay, let's try again. So we're going to evaluate this function when f is at negative 3. So again, you're going to take that negative 3 and you're going to plug it into the x value. So f of negative 3 equals negative 3 squared minus 4 times negative 3 minus 1. Okay, this part right here, this means negative 3 times negative 3. In the calculator, if you put negative 3 squared, it's going to tell you it's negative 9. you have to put the -3 in parentheses. So that's a 9. -4 times -3 is positive 12. Then you just bring down the -1. So 9 plus 12 is 21. Minus 1 is 20. So this is how you would write your final answer. Basically, you can think of this as like an ordered pair. At -3, you'd be at 20. So like on a graph, if you had to go over -3, you'd go up to 20, and that would be the graph. So it's like an ordered pair, -3, 20. Number 4, evaluating functions. Bowling costs $4.50 per game. The shoe rental costs $3.75. The total cost is a function of the number of games. What function rule models the total cost of games and shoe rental? Evaluate the function for 3 games. So first, we got to figure out our variables here. So 1, we know that we have the cost. And G, we could say that is the number of games that are played. We want to know the cost after so many games are played. So we would say the function is C of G. Now, we know that it is $4.50 per game. If you remember earlier, we said if you see that per word means multiply. So this is $4.50 times G. I could put the 0 there, but it doesn't matter in the decimal. So 4.5 times G plus the shoe rental. So this is the function rule that models the situation. But now I need to know the answer of the cost when I play 3 games. So this is my G. So I plug in, what is the cost of 3 games? So 4.5 times 3 plus the shoe rental at $3.75. 4.5 times 3 is 13.5. So that's like $13.50. Plus your shoe rental, and we have $17.25. So if you were to play 3 games and rent shoes, you would pay $17.25.